Hello guys, this is day 21 of our daily push-up challenge while doing some Putnam problems. This one right here comes from 1954. Let's do some push-up. I think this is gonna be a short problem, so let's do 10 first and then let's read the problem.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10.
Okay, so I'm late in posting today. Usually I do this during a lunch break, but I attended like an ongoing conference right now regarding, event generation. So we have to like insert this now while the conference like taking a break. But anyway, the problem reads: show that the equation x squared minus y squared equals a cubed has always integral solutions for x and y whenever a is a positive integer. So right on the what we can do is right away is we can factor out x squared minus y squared, right? We can write that as x plus y times x minus y equals a cube. Okay, and then let's say we let x plus y equals a squared, and then x minus y equals a. Of course, this implies that if you multiply it, this implies x squared minus y squared equals a cube, okay, which is what we are given here. So we will try to show that whenever a is a positive integer, then an integer solution exists for x and y. So we can solve for x and y here. So let's insert some push-up first. I think we should finish it now.
11, 12, 13, because I can see the answer on the horizon. 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25.
Whew, that was tough. But yeah, let's like I said, let's add the equation. So this gives you, when you add the equations, it gives you x equals 1/2 a squared plus a, correct? When you subtract both equations, it gives you y equals 1/2, let me see, a squared minus a. Okay, so let's look at this. Is x and y guaranteed to be integer if a is a positive integer? So let's look at the cases. When a is even, we have no problem, right? Because an even number, when you square it, okay, if a is even, right, a squared is also even, okay? Even number minus even number, you subtract it, it also gives you an even number. When you divide it by 2, then you have no problem with even numbers, because the issue with dividing by 2 sometimes is it can lead you with a non-integer solution. But when a is even, we're fine. How about if when a is odd? When a is odd, what happens when you square it? Well, a squared is also odd, correct? So when we have an a that is odd, when you take the square, it's also an odd number. We're doing a squared minus a, right? So what happens when you add letter a, when you add two odd numbers, or when you subtract an odd number from another odd number? Well, it gives you an even number, correct? So when a is odd, and then you take the square, it's also odd. When you add those two odd numbers, or you subtract those two numbers, it gives you an even number. So with that, when you divide it by 2, then you end up still with an integer. So right here, we have shown that x and y, for the cases where a is even or a is odd, are still integer numbers. Therefore, we've shown that there's always an integer solution for x and y whenever a is a positive integer. Okay, so I'm not sure if this solution is unique. There may be other solutions, for x and y, but we're just asked to show that it always has. So as long as you can find one, then you're done basically. But anyway, yeah, this has been day 21. It's been a short push-up session, but yeah, day 21 problem from 1954. 4 more days to go. Thanks for watching, guys. See you next time, and bye-bye.